exercise 3. We're doing 4.4 in trick 2. We're not going to do it for trick 2. And then now we're doing unit 5 out of the textbook, which is graphing, sine, and cosine. Yeah. Basically, if you know the unit circle, graphing these is hard. Remember in transformations when I gave you like y equals x squared, you guys could graph y equals x squared, and then I would give you a graph for the transformation of it, and you just move that graph around. Same thing here, we're going to learn the basic sine and cosine graphs and the pieces of them, and then we'll learn the transformations and moving them around. In logarithmic exponential, you use transformations as well, graphs and radicals, you use transformations as well, so you can't get away from transformations. So, if you look at your unit circle on the wall, some people are just memorizing these values. They're memorizing root 3 over 2 comes first, and you go 3, 2, 1, 1, 2, 3. But remember, the unit circle is actually coordinates on an actual circle, correct? So, if I look at this coordinate here, my x value looks like 3 over 2 or a half. 3 over 2 is bigger than a half, correct? Yeah. The 3 over 2 is 8, 6, 6, 0. So this coordinate here, the x value would be root 3 over 2, and the y value would be 1 half. You don't have to memorize it, it's a little point on the unit circle, right? So this makes sense to just be root 3 over 2 and a half, not a half root 3 over 2. Half of root 2 would be x 60, because that's half of x, because our x is up to 1, correct? And this root 2. So you don't need to memorize that. I find when you understand life is so much better than memorize. Memorizing causes the chance that you might not actually have memorized it correctly, and then you use it wrong. Okay? Now, every single point on the unit circle correlates to cos, x, sine is y, right? So when we go to draw the actual sine and cosine graphs, it's literally just the points of the unit circle plotted. And then we get ourselves a graph of this circle happening over time. So a Ferris wheel, for example, we're going to be dealing with lots of stuff about Ferris wheels. When you look at a Ferris wheel, let's say, some people want to start at the top of the circle. I don't know anyone who gets on a Ferris wheel at the very top. That would feel weird to say. They get on an elevator to get on the Ferris wheel to go around in this. So most of the time you get on at the bottom. And it's height over time, right? So we're taking this circle, and we're actually seeing what the heck it looks like over time. So when you do that, say, for example, you also don't usually get on a Ferris wheel at 0, 0, because your legs will break off. That would mean like your legs would like be under the seat and then it's done. You're just done. Or else you have to like tuck them up and then you like slide across the floor. It'd be very dangerous. So usually in Ferris wheels, you don't start at 0, 0. A tire, you can start at 0, 0. It's on the ground. Ferris wheels, probably not. So say we get on at 1 meter. Then after time, we're going to go upwards, right, to the maximum of the Ferris wheel height. And then we're going to come back down to that same height distance. So we're coming down. And go to the bottom, and then come back up. So over time, you get a graph that looks like this. Wavy looking graph. Sinusoidal or a cosine graph. Okay? They both look the same. It's a graph that's either transformed one way or the other. Okay. So let's look at these graphs. Transformations of sine and cosine. So period and amplitude. The period of a graph is how long it takes to repeat itself. So basically, if you're looking at the Ferris wheel, it's how long it takes from when you get onto the Ferris wheel to when you get back to that same spot. That's the period, the time length. The time it takes to do one full revolution of the circle. That's the period. Okay? And the amplitude is the height. So the amplitude is from middle up, middle down. It's like it's from your median line up and your median line down. So let's look at this. Sine and cosine graphs are both periodic functions. Periodic meaning they repeat themselves over and over and over and over. The only way they're going to stop repeating themselves is if you restrict the domain. You say, okay, between 0 and 2 hours, how many times you can draw the graph? You can draw it and then you stop because they stopped at 2 hours. You're so sick of being on that Ferris wheel, you just want off. Okay? The periodic function is called sinusoidal curves. As a point rotates around, so like a point or a person on the Ferris wheel rotates around, they make themselves a graph, right? So here the motion and value repeat themselves. So at 45 or 405, the point would be the same. So you can figure out what your period would be. We want to graph the rotation angle versus the corresponding sine value of each rotation angle. What does that mean? Find your point. Plot. All right. So we're going to use, for this one, it's the sine function. Sine is what point on the unit circle? So like 0, what is sine on the unit circle? 0. Okay. And I'm going to do pi over 2 just because I feel like it. But you could do, let's do pi over 6 first. You want to do pi over 6? Is it easy to plot? This is the catch. People don't know what these labeled are. They know the labeled ones, but then the ones that aren't labeled are like, I don't know. Easiest way is to label those ticks in between is find pi and see how many times it's cut up. Okay, so pi is here. It's cut up 1, 2, 3, 4, 5, 6 times to get me to pi, right? So every single one of those ticks is going to be pi over 6. Because this is pi divided into 6 ticks, right? Pi over 6 is pi divided by 6. So this would be pi over 6. This would be 2 pi over 6, which is just another pi over 6. 2 pi over 6 is the same as pi over 3. And this would be 3 pi over 6. What's 3 pi over 6 reduced? Pi over 2. So it's actually that, right? And this would be 4 pi over 6, which is 2 pi over 3. And this would be 5 pi over 6. Whoa. It doesn't reduce anymore, and it doesn't. And this would be 6 pi over 6, which is pi. What would this be then? 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, and you can keep going on forever with all the ticks. So as long as you find pi and find out how many times it's cut up, you know what each tick is. Okay? So pi over 6, what's my sine value of pi over 6? Remember, we're using the unit circle. Sine is 1/2. This is the y value. I'm going to make this be 1 and negative. So pi over 6 and 1/2. 0.5. Okay. A pi over, let's pick the thing in the middle. 2 pi over 3 is there. A pi over 3, what are we at? 3 over 2. And what's 3 over 2? The 3 over 2, I think it's 0.866. Try it out. What do you get? 3 over 2. So we're going to be kind of guessing on that one, right? So 6.75 to 0.866, somewhere in there. And then at pi over 2, what is it? Pi over 2 is 90. At 90 is 1, right? 0 and 1 is 1. So then at 90 is 1. Then at 2 pi over 3, what do I have? Go on your unit circle. 2 pi over 3, I have root 3 over 2, so 0.866. And then 5 pi. Then 5 pi over 6, I have 1/2. And then at pi, I have 0. Then I can keep going, right, all the way to 2 pi. So then I can go to 7 pi over 6. What's 7 pi over 6? What's the y value or the sine value? Negative 1/2, right? So for the next one, negative 1/2. Then negative 0.866. Not either. Then negative 1. That's 3 over 2. Then negative 0.866. Then negative 1/2. So you have a graph like this. Now why, okay, on the unit circle there's just those points. Why am I connecting it? Why wouldn't I just plot points and down? Because that's all the points that are on the unit circle. Are those all the points that are on the unit circle? No. Are those the exact values and just points I picked? Is there points every single line, on that line that makes the whole unit circle around, there's a point on there, right? So there's a whole bunch of points around that whole circle. So I'm going to connect them because these represent all the little points between those exact values in the circle, right? So unit circles are just those exact values we drew. There's points the whole way through. So that's how you connect them. So your sine graph starts at 0, 0. It's not translated. Why? Because at 0, my y value is 0. At pi over 2 or 90 degrees, my y value is 1. So people are memorizing this one. Okay, sine starts at 0, 0, and then at pi over 2 is 1, and then at pi it's 0, and then at 3 pi over 2 it's negative half, and then, or negative 1, sorry, and then at 2 pi, and they just memorize. Why memorize? Remember, what are you making sure you do in your test? Drawing out that unit circle. So why is it so important to draw the unit circle? Well, it helps with all of the lessons we've done so far, right? Make stuff way faster. And this, you don't have to memorize anything. Your points are on the unit circle, you just plot them. Okay? So is close going to be hard to draw? No, we're going to do the exact same thing, but instead of taking 0 in the y, or 0 degrees in the y, we're going to be 0 degrees and the x, so it'll be 0 and 1 every close graph starts with 0 and 1 instead of 0, 0. Right? Okay. So period, the length of the interval of the domain over which a graph repeats itself. So basically, the period of this graph that I just drew is how much? How long does it take? Yeah. 2 pi. Some people say, well, pi is the same little loopy-loop as this. Well, no. This goes like this, and then what would happen? I would start repeating myself. I'd go up and back down, and back, and then I repeat myself. So I get to 4 pi. Then I go down and back up, and I get to 6 pi. Then I get down and back up, and I get to 8 pi, right? So it repeats itself every 2 pi. So the period of a sine graph that has not been stretched, it's translated okay. If I took that graph and I translated it horizontally this way, or I translated it horizontally this way, is my period going to change off? No, it just shifts the graph over. But it's still going to be wherever I start from to wherever I end, 2 pi. But it's 2 pi, so it's shifting it to left, right. If I move it up or down, is that going to change my distance between this and this? No. If I vertically stretch it, so I pull it up or pull it down, it's going to change my what values? Y values. When I vertically stretch, it changes my y. My period is based on my x. So is that going to change my period at all? No. What's the only thing that can change the period of a sine graph from 2 pi to something else? Yeah. Yeah, so a horizontal stretch goes y-axis. That's the only thing that's going to change the period, right? Other than that, for a sine graph, your period is 2 pi. It isn't always. If I have a horizontal stretch, you can change it. Okay? So normally, for this one, the period will take the following for sine theta. This is sine theta. There's no horizontal stretch, right? So my period is 2 pi. My amplitude. Amplitude is half the difference between the maximum and minimum values of a periodic graph. So basically, if I could draw like a middle line in the graph, called a median line or a midline, so when I draw that middle line that horizontally cuts the graph in half, like, so I guess vertically cuts the graph in half, that distance from middle up and middle down is going to be your amplitude. Okay? So, y, will there be absolute values on the max and min? What does an absolute value make anything do? Yeah, stay positive. What did I say the amplitude is? The distance from here to here, from here to here. The amplitude is always positive. This is the distance. So remember that. Amplitude is always positive. So, on the diploma, they gave me the answer for the amplitude, and one of the answers is negative something. That was out. Gone. Amplitude can't be negative. Okay? So what's the amplitude of this graph? Well, let's figure it out. It's going to be the actual value of the max. What's the maximum that graph goes to? What's the highest it goes to? Yeah? 1. Minus. What's the lowest it goes to? -1. So it's actually minus a -1, right? That's value divided by 2. So 1 minus a minus 1 is actually 2. Active value of 2 over 2. The active value of 2 over 2 is 2 over 2, which is 1. So we're saying that this graph has an amplitude of 1. Does that make sense? Well, from the middle of the graph, which is here, this is the middle of my graph, right? 1 up. Is 1 down. It's right on right. If you go to draw the graph and you're like, it's 7 up and 7 down, I'm getting 1. You made a mistake. Go back, try again. The domain of a non-restricted sine graph. This is literally a graph that's restricted between 0 and 2 pi, only because that's the only part I gave you, right? But does it keep going this way? It can, yeah. Can you keep going to the right as well? Yeah, forever and ever and ever. So domains of a sine graph, unless it is restricted, which if they restricted it, they're not going to ask for the domain. What's the domain of sine theta between 0 and 180? You'll be like, 0 and 180, why are you asking for the domain? You told me the domain, that's silly. So they won't do that. Should. So the domain is SCR unless they restricted. I can write it like this, or I can write it like round bracket, negative infinity to infinity, round bracket. And it's round brackets because it's not equal to, you can't ever equal infinity. Infinity is not a number, it's a concept. Okay? What's my y-intercept of sine? Where's cross y-axis? Yeah. 0, 0. The y-intercept is 0, 0 for sine graph. Unless, of course, it's been translated or moved up and down, then it totally takes that 0, 0 and moves it, right? I'm just going to 25 guys. What's my range? My range for every sine and cosine graph can be between 2 values, because I have a maximum and a minimum on every sine and cosine graph. My maximum is 1 on this graph. My minimum is negative 1 on this graph. So my range is going to be y such that negative 1 is less than or equal to y is less than or equal to 1 YDR. Now, it's equal to because it actually reaches that height, right? And low. So some people just put the less than sign and greater than sign. It's equal to. It's not an open dot on the top, on the highest maximum point, and an open dot on the lowest. And then if I do an integral notation, it's going to be square bracket is equal to negative 1 square bracket. Now, I told you this graph goes on forever and ever and ever and ever and ever, unless I restrict it, right? So my intercepts are happening at 0, then again at pi, then again at 2 pi, then again it's going to happen at 3 pi, and then 4 pi, and then negative pi, and negative 2 pi, and negative 3 pi, and negative 4 pi, and negative 5 pi, and oh, it's going to keep going. That was supposed to be fun, isn't it? So, you're not going to write 0, negative pi, negative 2 pi, dot, 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 pi, 2 pi, dot, 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 dot. Although that would get the point across, that's not how we write it. So we're going to write it as a general solution, just like we wrote general solutions for coterminaling, right? So, we could write this. We could write theta equals, the theta intercept. Theta would equal, the first one that we start at is 0. So we could write 0, kind of silly, but we're going to write it for now. And then we could go plus, how much more do I have to go to get to the next one? Pi. So it's going to be 0 plus pi and any I. So if I fill in any integer, just like we did with coterminal, it's going to get me all the positives and all the negatives, right? So, plus pi and any I. Now 0 plus pi n looks ridiculous. So what we actually just write is pi n any I. Because that 0 is going to actually do nothing if you just put 0. Make sense? So if we want to actually put this into our calculator, we're going to go to y equals, and you're going to put in sine x. Now, depending on what your calculator is, like whatever it is, if you want to put it into okay. If we want to make so if we want to put this into our calculator, we have to look at our x-axis. Our x-axis is in radian mode or degree mode. Oh, thank you, radian. Thank you. It was so fun to told you to tell me. Good job. So it's in radian measure. So we need to know that our calculator needs to be in that mode then. Okay? So make sure you put your calculator in that mode, and let's figure out what the heck to make our window be so that it looks exactly the same. Because if you want to compare your graph, you want to compare, if you're comparing the graph on a test that they gave you, you want to make your window be the exact same there. Yeah. So if you want to compare graphs with their graphs, make sure that you make your window be the exact same as theirs. So we know we need to have it in radian mode for it to look like this one. So we have to in radian mode. Now, x min comes first because that's what it comes on the calculator. So what's your x minimum? If we want to make ours the exact same as one that's on our paper. 0. X max. Good. X scale. X scale is what the heck are the 6 going up by? What do we decide the 6 are going up by? Right? What do we decide? Yeah. This is one of the 5, 6, 8. So we'll make our x scale be pi over 6. You'll type in pi over 6 and it'll give you the crazy decimal, whatever the heck pi over 6 is. But you'd rather have that because it keeps the decimal places, all the decimal places in that spot. If you just do pi over 6, find out what it is before decimal places and put it in, it's not the same. So always put in pi over 6. It'll lay out all the crazy decimal, but it keeps them all. Okay? And we do y minimum. We have the y minimum as -1. The y maximum is 1. And then there's 4 ticks to get us there. So our y scale would be a quarter. Or we could put 0.25 because that's terminating this, right? Then you do y1, make sure you have sine x, and press graph. Should get the same graph. Did everyone get it? Did it work? So the key thing is when you're comparing graphs of any sort with any unit, whether it be log, exponents, trig, make your graph be the exact same as their graph. Because what I find is you'll find your equation and you find it correctly. You compare it to their graph, but not the same like scale, like not the same x and max and min. You're like, they're not the same. Well, they actually are. Your window's just different from theirs. So make sure your window's the same so you're comparing apples to apples, not apples to oranges, and hopefully it's the same. Right? Okay. Now, what if I did it in degree mode? So for degrees, you want to make sure that it's degree mode, and you could do -360, 360, and it goes up by 90, -221. If we want it to be the exact same as the graph we have up there, we go -360. Was it -360? Is that our minimum? No, our minimum was 0. So if we want to compare it to that graph, we have 0. 2 pi is 360, and we need to go up by pi over 6. And what's pi over 6 in degrees? 30. And then does our y change whether it's in degrees or radians? Our y isn't affected at all by radians, right? It's height. So our y we would have -1, 1, and then 0.25, or a quarter. And this is how they can write it. So if they want a specific window for you, this is how they would write the window. So they'll go x min, x max, x scale, y min, y max, y. Okay? Instead of writing x min, x max, x scale, they'll write it like that. Okay, flip over. if using sine graph cos theta off from using point off the unit circle. So you're going to use the radian measure with the x variable. Okay, you try it. So you go to 0 and 1. Then pi over 6 would be the first bit. And then this would be a half. And pi over 2 is 0. Here's the negative 2. Half. Negative 1. Okay. So you can tell it's periodic, so that means that so it looks like that. If I don't tell you this is a cos graph, and I'm telling you the equation, could be a sine graph. Does it make the same whoopty-woos, just like mountains and hills, just like sine graphs? Yeah. Cosine graphs and sine graphs can be the same thing. So I can ask you, you can look and see like, this really represents a cos graph. And I say, okay, what's the equation of this sine graph? So let's see, here's the cos graph. Okay. All cos graphs and sine graphs are transformed equations of each other. Because don't draw it through what those contribute to later on, you'll be like, which one was what? But remember, it was like this, then it was like this, then it was like this, then it was like that, back up here. This was my sine graph, that's just true. Right? Yeah. Yeah, in German. A little giggle out there. All right. So the sine graph is literally what is the cos graph? What's happening? Is it any higher? Is it any lower? Is it stretched at all this way? Is it stretched at all this way? No, it's literally just translated. That's all it is. It's just a horizontal translation of each other. So you could say that the cos graph is the sine graph moved pi to the left, right? The cos graph is moved, the sine graph moved pi to the left. Or I could say that the sine graph is the cos graph moved pi to the right. They're literally just a translation of each other. If I move one of them pi, then you're going to talk to each other, right? They would be the exact same graph. Make sense? So it's literally just a rotation. It's like taking that circle and rotating it pi, and then the numbers are all actually overlap. Like that. Ask it. No one can hear anyway. Okay. Oh, pi over 2. Because I'm saying pi, but I was just saying if you were paying attention. Yeah. This is why you ask questions. Catch my instinct. Don't quietly ask someone else. And they know, now they know what to do. And I'm sure they're Okay, so it'd be pi over 2 shift, right? A pi shift would totally move past what the other one was. So don't mess up to that. So we did a quarter of a shift, a half a shift. We did a pi over 2 shift. And just turned our circle, took it, and we're just like, yeah, they would be on top of each other, right? Okay. The amplitude, did it change? No. The amplitude, would it change if I did a horizontal translation? If I took the graph and I moved it horizontally, would my amplitude change? Would my range change? No, I'd just be shifting it this way. If I did a vertical translation, would it totally change my amplitude? Yeah, we take whatever it was and we shift it up, or we take it and shift it down to change my amplitude. Or my amplitude, sorry, wouldn't change. My range would change. My amplitude would stay the same. So if I vertically translate something up and down, does the actual amplitude change? Does the graph change in amplitude? The distance from middle up, distance from middle down? No, the graph would be like this, height, low and high. Move my amplitude up, my amplitude's still the same, right? Take that, move it down, my amplitude's still the same. Is my range the same? If I take that and move it up, my range is going to be between this value and this value. If I take this and move it down, my range is now going to be between this value and this value. So my amplitude will stay the same on the vertical translation, but my range won't. Does that make sense? All right. So my amplitude is still what? 1. So from the median line middle up, the median line middle down is still 1. It's still the absolute value of my mass, which is 1, minus my min divided by 2. So it's still 2 over 2 or 1. My domain, so I see it. Or negative infinity. My y-intercept is the same as the previous one. My y-intercept for the sine graph is 0, 0. My y-intercept for the cosine graph is 0, 1. The period of my graph is still 2 pi. So it repeats itself every 2 pi. It's just, if you look at it, it's still repeating it. It's going to a max, back to a max, right? It's still 2 pi. And then my range didn't change. Negative 1 is less than or equal to y is less than or equal to 1. Or negative 1 equals 1. Do my theta intercepts change, which is just my x-intercept? Theta intercepts is a fancy way of saying an angle intercept. Do they change? Yeah, because where's my first one happen? Yeah, so pi over 2. So this time I would say theta equals, instead of 0, it's pi over 2. So I'm not going to get rid of it. That's pi over 2 plus. Now, how much does it take till I get to the next one? Yeah, 5. Because pi over 2 to 3 pi over 2, right? If I go 3 pi over 2 and I subtract off pi over 2, that's just pi. So it still takes pi, so it repeats to the next exponent. Pi and then it would do the same thing. Okay. As discussed earlier, amplitude is maximized when the absolute value is the distance, right? However, the amplitude is also directly related to the A value. So your vertical stretch, technically, is here, right? Maybe in front, just like it was before. That is your amplitude. You have to watch yourself, though. If I gave you y equals negative 3 sine theta, people will tell me my amplitude is negative 3. Can my amplitude be negative? No. So my amplitude, instead of 80 right now, my amplitude actually equals the absolute value of my A value. So if the absolute value is negative 3, so my amplitude for this one would be 3. Okay? I can't tell you how many of you, I'll give you y equals negative 3 sine theta, and I'll ask for the amplitude, and you will graph the graph, and then you will find the maximum value, you will find the minimum value, you will subtract them, you will divide by 2, and you'll find out it's 3. When you could have just went 3. Literally. So remember that A value, the absolute value, A value is absolute. Done, move on. People will graph it out and use the formula, max minus min divided by 2. Thinks you way more time. Okay? So the A value may be negative, however, amplitude is always positive, therefore amplitude is the absolute value of A. Now remember, you guys told me when I was talking about the period of the graph, I said to you, what affects the period of the graph? I said, does the horizontal translation affect the period? Moving to the right, moving it to the left. If this is the period of the graph, and I move it to your right, did it change the period of the graph? Is it the same distance period? So the period is horizontal distance, right? Of repeating. Nope. Now if I take it and I move it to your left, does the period of the graph change if I actually held my hand properly? No. Move it up, does the period change? Vertical translation, move it down? Nope. If I stretch it vertically, does it change my distance? No, because vertical stretches affect my y. So if I just have a vertical stretch, all my y's be multiplied by that. But what happens to my x's? They would stay the same, so my period doesn't change. So what's the only thing that changes my period? Horizontal stretch, right? What's the horizontal stretch? The value in front of the x value, or theta in this case, or a, or w, whatever the heck the other variable is, okay? So for this one, it's theta. So that b value is going to change my period of my graph, correct? So that's why we always do the period of a sine or a cos graph, because remember the original period of every sine and cos graph is 2 pi. If I stretch it though, it'll change the period. It'll either narrow it in or make it bigger. The period of a graph is of sines and cos graphs, sorry, I should say, because if it's a tan graph, this is not the case. So a sine or a cosine graph, the reason I put e's on is because it's sin and it's tries to be bad. So sine and cosine graph is 2 pi divided by the absolute value of b. Because that b value is actually going to shrink my period or expand my period. Okay? Now you put the b value in for what the b value is. You don't like b is 7 and you say, okay, well, it's a horizontal stretch of a 7. Yes, it is a horizontal stretch of a 7, but b value is the b value. You just insert the b value, whatever it is. That makes sense? So yes, if it was a 7 in front, you'd have a horizontal stretch of a 7 because your horizontal stretch will split, but your b value would still be 7. It doesn't change. Put that in. Okay. So the difference between this is if it's in radians, you do 2 pi divided by the absolute value. If it's in degrees, there's a little degree symbol, or that would actually be radians. You 260 degrees divided by the. Okay? Move on. Okay, state the period and amplitude of each of these. So my amplitude is just the absolute value of A. What's my A? 2. What's the absolute value of 2, which is 2. The period of the graph the only way you can tell if it's in degrees or radians is if there's a horizontal translation, just so you know. So if there's a horizontal translation, which would say 3 theta plus 30 degrees, then you would know it was in 30 degrees. I'm moving at 30 degrees to the left. If this would be a half theta minus pi over 2, then you would know that it was moving pi over 2 to the right, and then it would be in radians. So unless, if it doesn't give you a horizontal translation, it would have to give you a domain or something to tell you radians and degrees. Remember, you guys, remember in transformations I told you you have to take the horizontal stretch out? Same thing here. If I gave this to you as like pi over 2 theta plus 3, you'd have to take the pi over 2 out and have theta plus 6, right? And then time your shift. The same transformation rules as before, nothing has changed. You're just literally transforming a sine or something. So the period of this graph, I'm going to use 2 pi for these. And 2 pi divided by the absolute value of b. So it's going to be 2 pi divided by 3. Done. Don't turn it into a decimal unless it's in the next box. Yeah. Look, because it's 2 pi divided by the b value. So the b value, your formula is y equals a sine b theta. So So B is literally what's in front of theta. If you were saying horizontal stretch by a factor of blah, 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 you have to say horizontal stretch by a factor of third, right? And it was like, but the B value is 3, yeah. Okay. So what's the amplitude of this one? Absolute value of A, which is absolute value by half. This half is a negative and another. And then my period is 2 pi divided by B. Sorry, absolute value of B. So 2 pi divided by a half. You divide by half, it's like multiplying by 2. So got it? Okay, so the transformation has occurred. Vertical stretch by a factor of 2.5. 2 is not with the y. About the x-axis. Vertical stretch meaning my point was xy. My point is now going to be x 2y. Remember, whenever I'm comparing a graph to a graph, I also need mapping. Because then I can take all my original points, I can do my mapping to every single original point this new one. So basically all I'm doing is I'm changing all my y's and multiplying them by 2. Okay? If I multiply my y's by 2, does that change my amplitude? If I take every y and I multiply it by 2, what happens? If it's at positive 2, it's going to now be at 4. And if it's at negative 2, it's now going to be at negative 4. And instead of my graph only being this far apart, it's now going to be way further apart, which means my amplitude is going to change. Okay? The amplitude changes. Now, my range is like this. My range is now like this. The range is going to change too, right? Okay, my graph was like this. So its width was like this. Does the x change at all? No, and the x is what my period is based on, correct? Does my period change? No, because my x is not change. Just no x. My period is still there. Does my domain change at all? No. Even if I had a restricted domain, it would still be restricted to that same amount because the x value. My x-intercepts, do they change? X-intercepts are when y equals 0. So, if my value is at pi over 2 and 0, the only thing I'd be multiplying would be the 0 by something. When you multiply 0 by something, what happens? It stays. So, do my x-intercepts change? No. Do my y-intercepts change? If my y-intercept was at, this is close graph, so my y-intercept was at 0 and 1, it's now actually going to be at 0 and 2. So it changes. How can the amplitude range be found without actually graphing? This is huge. This gets asked in the diploma a lot. Okay? What you need to know is the amplitude is the distance from the midline or the median line up and the midline and the median line down. Correct? The midline or median line is that line that cuts the graph in half. It's that horizontal line that cuts the graph in half. It is your D value. It is your vertical translation, which we'll learn tomorrow. So back here, my D value, if I don't have one, it's just going to be 0. Okay? So technically, my graph right now, because I have a vertical translation, it cuts itself in half right on the x-axis. Okay? So if I take that D value and I add to it the absolute value of my A value, because the absolute value of my A value is the amplitude. So if I take that D value, the middle line, and I add to it my amplitude, I'll get the max, right? If I take that D value and I subtract from it the amplitude, I'll get my sin. So if you want short form, you don't have to graph it. Your max is always your D value plus your amplitude for your absolute value, and your minimum is your D value minus your absolute value of A. It just happens that our b values for all of today's lessons will be 0 because we're not doing theoretical translation, right? We're just doing structure. So it's going to be 0 plus 2. So I have maximum at 2. The minimum at 0 minus 2 is negative 2. So my range, my amplitude would be what? My amplitude is the absolute value of A. It's not the square. The absolute value of 2. That's 2. And my range is just going to be between negative 2 and your y. And it's going to be equal location. It's going to be between negative 2 and 2. Alright? So y equals sine 3x. So my point would be xy. My new point is going to be a third x. So I want you all to say the same. The chances I'm only just putting this one stretch on, pretty slim. They're going to probably put all the transformations on for some of them. This lesson is awesome because we haven't done any of the others. This is a horizontal stretch by a factor of a third above the y-axis. But what is my b value? To find a period. My period is 2 pi divided by b. What's my b value? 3. The b value is the b value. It is 3. It is horizontally stretched by a third, but the b value is 3. Please don't put a third in. Okay? So my amplitude, does it change? My amplitude is my y values. Are my y values changing at all? No, they're staying the same. My amplitude changes. My y values stay the same, my range stays the same. The period of the graph, it's going to be 2 pi divided by what now instead of 2 pi? 2 pi divided by 3. My range or my period changes. And my domain, if it was restricted, would change. But if this is an unrestricted domain, it doesn't matter that it does this instead of doing this. It would still be the same domain technically. If it was a restricted domain, it would be restricted to something smaller. So this is kind of a trick question because it's like, well, was the domain restricted? Then yeah, it changes. If the domain is not restricted, it's XCR to XCR. Right? Does that make sense? So I'm going to box it because if it's a restricted domain, then yes, it changes. If the domain was XCR, it's still going to be XCR. Your graph is just going to possibly go like more often or big. Okay. Now x-intercepts, they change because all my x is going to multiply something my y are going to stay the same. And my y-intercepts will stay the same because my y-intercept x is 0, multiply it by a third, stays 0. Okay? Same thing again, max and minimum. Max is going to be 0, so d value is 0, I don't have one. Plus, what's my amplitude? What's the absolute value of my A? What's my A if there is nothing? Is it 0? It's 1. If it was 0, what would happen? 0 times sin of 3x is actually 0. So it can't be 0. People tell me 0 times. It can't be 0 because then this whole equation would be gone. You're just times it. So it's a 1. So it's going to be 0 plus the absolute value is 1. So 0 plus 1, which is 1. And then my minimum is 0 minus the absolute value of 1. Is 0 minus 1, which is negative 1. So my amplitude is just 1. And my range doesn't change to my original graph. It's negative 1. All right, so flip to the summary part. The period of y equals sine theta is. What's the period of just the y equals sine theta graph? 2 volts. True or 2 pi. And then cosine is 2 pi as well. The parameter being in the equation f of dx for f of x is sine x or f of x with cos x results in what? A change in the? What does the b do? It changes the grid.
So we're going to ask for like a clear line for the sine. Just for like, for example, we're going to want 2 pi, because they want 60 degrees, they don't want
Well,
specify.
if they don't specify, they'll find a way to specify it, like not putting both answers in multiple choice. And if it's numeric response, they would have to show you like a restricted domain so that you would know if they wanted radians or degrees, right? Okay, this means B gives the number of cycles in 360 degrees for sine and cosine, or 2 pi. The period can be found by using the formula 360 over B or 2 pi over B. If asked for a period in radians, you can either use the radian equivalent of the above or get the period in degrees and convert to radians. Personally, I would just go 2 pi divided by 3. Now you're going to be going 360 divided by 3 is 120, converting that to radians. Like sometimes converting to degrees first and radians is not easier. But some people really love degrees. Okay? So, what I want you to do is flip past this example over to example 2. So we want to describe the transformations in words and create the mapping to the function below. For the graph, y equals 2 sine 3 theta between negative 360 and 360. We want to graph it out to negative 360 and 360. So if we do mapping, our x, y coordinate is going to become what? What's going to happen to my x? Multiplied by what? With x. A third, right? Because your horizontal stretch you multiply your x's by. And then your y is going to be multiplied by 2. You can say I have a vertical stretch by a factor of 2 about the x-axis. And then a horizontal stretch by a factor of a third plus y. So you could literally draw the original graph and translate it, then you have 2 graphs on one. You can do that. Or you can do mapping, which whenever, remember, I'm taking an original graph and I'm moving it. When we did expert graphs and moving them, we used the coordinate 0, 0, with 2 and 4, negative 2 and 4, 1, 1, negative 1, 1, right? We did all of those points, then we map them, we change them. So same thing here. You're going to have to go and get the original sine coordinates. Where do you go to get our original sine coordinates? Unit circle. Okay? So you can pull them up in unit circle. 0, 0, at 90 it's 1, at 180 it's 0, at 270 it's negative 1, at 360 it's 0. Now I'm going to map them. I'm going to change them. So my x is going to be multiplied by a third and my y is going to be multiplied by 2. 0 times a third is 0. And then 0 times 2 is 0. So that didn't change at all. 90 times a third is 30. 1 times 2 is 2. So now I'm at 30 and 2. Now I'm at 30 and 2. This is 45, so 30 is a little shy of it. If you were labeling your own axis, you probably wouldn't label it like this. You'd make a different axis, right? 30, 30, 60, 90. I don't know why I did this. And then 180 times a third is 60. Which is basically divided by 3. 0 times 2 stays 0. So now we're with 60 and 0. Oh, I shifted the whole thing up. 270 and a third is 270 divided by 3, which is 90. And negative 1 times 2, negative 2. Three 60 divided by 3 times a third is 120. 0 times 2 is 0. So if I wanted to draw this negative 360 and 360, I'd have to get a lot of points, because this baby's going to repeat itself a heck of a lot more than it did before, right? Why? Why is it shrunk so much? Why is it so much more narrow? Period of a graph is normally what? The period of just basic old line graph is 2 pi, right? The period of this graph, however, is 2 pi divided by what? And remember, a plain old sine graph is sine theta. What's in front of theta? What's the b value in front of theta? A 1. It can't be a 0 where theta will go away and it doesn't make any sense, right? So that's why the period of sine is 2 pi over 1. So the period of the sine graph is 2 pi because b is 1. Well, in this case, b is actually 3. So this graph repeats itself every 2 pi over 3 instead of 2 pi. So that means 2 pi cut into 3 pieces, right? So instead of you normally having a graph between 0 and 2 pi, one graph, you're not actually going to have 3 cycles of that graph, right? So this number down here tells you actually how many cycles you're going to end up on this graph. You normally would. So normally in 2 pi I have 1 cycle, 1 rotation. Now I'm actually going to have 3 because it's actually cut up into 3. Okay? I will give you what homework you can do and we'll finish the last little part tomorrow. So if you go to the homework section,